Welcome to Applied Math Lecture 3, Part 6. Operations with decimal numbers. Get ready. Here we go. Okay, so we're going to now do some operations with decimal numbers. All right, let's start with addition. Okay, the important thing to remember with addition and subtraction is that the decimals must line up with each other. So it doesn't matter if you have one of the numbers has only one number after the decimal, one digit after the decimal, and the other has three. You just have to line up the decimals with each other. So we've got them lined up here, and with this subtraction we have them lined up. So that's good. So now when we're adding, any blanks that we have, we just fill in with. You don't even have to write it, but I'm going to put in these ghostly zeros just to remind us that those are to be treated like zero. Okay? So we just, at this point, we're just going to add like they were any other numbers, and the decimal will just stay in the same place. So 0 plus 2 is 2, 0 plus 1 is 1, 9 plus 4 is 13, so that's 3 and carry the 1. 1 plus 7 is 8, plus 8 is 16, carry the 1, and we have 1 plus 3 is 4, plus 2 is 6. So we have 37.9 plus 28.412 is 66.312. Okay, now moving on to subtraction. Okay, once again, we line them up with the decimals, but you have to be careful here. All right, with a subtraction, any blank spaces, make sure you fill those in with zeros. Okay, because otherwise you're going to be very tempted to go, oh, nothing minus 2 is 2. But that's not the case, right? It's not the case with subtraction. We have 0 minus 2. You can't do it. You need to borrow, right? So we're going to borrow from above. We can't borrow from this because it's a 0, so you got to borrow from the 9. The 9 becomes an 8, so the tenths column, sorry, the hundredths column becomes 10, which becomes 9, and the hundredths column becomes 10. 10 minus 2 is 8. 9 minus 1 is 8. 8 minus 4 is 4, and now the decimal stays in the same spot. 7 minus 8, oh, can't do it, gotta borrow again, that's a 2 there. 17 minus 8 is 9, 2 minus 2 is nothing, 0. We don't have to write it because we're at the beginning of our number now. So that's 9.488 is the answer to what is 37.9 minus 28.412. So there's addition and subtraction done. Okay, now let's take a look at multiplication. All right, with multiplication, something very different happens. All right, we basically just disregard the decimal points entirely until the very end. So 3.75 times 2.5 is going to look exactly the same as 375 times 25 until the very last calculation. All right, so let's give this a shot. 5 times 5 is 25, so that's 5 carry the 2. And then 5 times 7 is 35, plus 2 is 37, carry the 3. 5 times 3 is 15, plus that 3 is 18. Okay, now we're going up to the next place value, so I'm going to put a 0 down. And I get rid of my chicken scratch from before, and now I have 2 times 5, so that's 10. 2 times 7 is 14, plus 1 is 15. And 2 times 3 is 6, plus 1 is 7. So now we add all this up. We have 5 plus 0 is 5, 7 plus 0 is 7, 8 plus 5 is 13, 1 plus 7 is 8, plus another 1 there is 9. So the digits that I'm going to have are 9, 3, 7, 5. Now the question is, how many of these digits are actually on the right side of the decimal. And the way that you can figure that out is by looking at the decimal points up here, okay, and seeing that there is 1, 2, 3 decimal points. There's 2 in the first number, 1 in the second number, so that's 3 total points there, and that's the number of decimal points in our answer. So it's going to be 1, 2, 3, so we'll have 9.375. All right? Just for a quick explanation of why that is, let's instead interpret these as fractions for a moment. 3.75, that's 375 over 100. All right? And we're multiplying that by 2.5, which you can interpret as 25 over 10. And we know that to multiply fractions, we're just going to multiply numerator times numerator, so 375 times 25, which is 9,375. How do I know that? Because I just calculated it here. Okay, and over 1,000. Okay, and now dividing here, I'm going to have 1, 2, 3 spots moved over from the decimal point, because that's how you divide by 1,000. Okay, so that's how this works. We end up moving the decimal the exact same number of spots that it was moved by each of these two numbers. So it's been moved twice by the first number and once more by the second number. So that's why we end up with 3 decimal places in our final answer. Okay, so there you go. That's multiplying with decimals. On to division. Okay, so with division, things get a little weird. Okay, in multiplication, we were able to pretty much just ignore the decimal places until the very end. With division, since it's multiplication backwards, we pretty much have to deal with the decimal places immediately. All right, so what we want to do here is write 2.5 going into 3.75 like this, but the problem here is I can't deal with the decimal being in my divisor, okay, using the long division format. So what we're going to do is multiply both our divisor and our number we're dividing into here, 3.75, by 10. Okay, so to use fractions to explain what we're doing, this number here that we're writing is 3.75 over 2.5, and I'm just going to multiply the numerator and denominator by 10. All right, so what I'll have then is 37.5 divided by 25. And since this is basically a fraction, right, I'm multiplying by 10 in both numerator and denominator, so I get an equivalent fraction that will have the same amount. So what I can do then is write 25 going into 37.5. Okay, and this I can do now. All right, I can say, okay, 25 goes into 37 how many times? Well, once. And what happens with this decimal is you just fill it in. You put the decimal right above where it is in the house here. So in this tableau, you just put it right above. So we're going to have 1 times 25 just like before, and we subtract. 7 minus 5 is 2, 3 minus 2 is 1, so we have a remainder of 12, and then bring down this 5. 25 now goes into 125. How many times? Well, it turns out that it's exactly 5. So 5 times 25 is 125. We're subtracting, and we get a remainder of 0. So going back to our original question, 3.75 divided by 2.5 ends up being exactly 1.5. Okay, I'm going to do one more example to show how things can get a little strange, let's say, with decimals and division. But it shouldn't be too much of a problem. Okay, let's try, how about 6 divided by 0.7? Okay, this will be interesting. Okay, so in order to do this, what I need to do is multiply both by 10 because I don't want any decimals in my divisor. So what I would originally write is 0.7 going into 6, but I need to multiply both by 10. So that way I'm going to have 7 going into 60. Okay, so 7 goes into 60 8 times. 8 times 7 is 56. So that leaves me with a remainder of 4, right? So I could, at this point, say something about a remainder of 4/7, but that doesn't really make sense. When I have a decimal in my question, I should probably answer with a decimal. So let's keep going. What I can do is say this is 60.00000, let's say. Okay, so what I'm going to do is bring down a 0 now and ask the question, okay, I put the decimal up here. 7 goes into 40 how many times? And it's 5, because 5 times 7 is 35, right? If this is a surprise, then do more practice with your multiplication. But yeah, 5 times 7 is 35. So 40 minus 35 is 5, and I bring down the next 0. 7 goes into 50 how many times? Well, it's 7, because 7 times 7 is 49. And then 7 goes into 10 how many times? Well, it goes in exactly once. 1 times 7 is 7, which gives me 3. 7 goes into 30 how many times? 4 times. 4 times 7 is 28. 30 minus 28 is 2. And bring down the 0. So 7 goes into 20 how many times? Well, twice. I'm going to put a few more zeros here. Twice. And 2 times 7 is 14. 20 minus 14 is 6. Bring down the 0. 7 goes into 60 how many times? Well, it goes in 8 times, because that's what we had up here. And 8 times 7 is 56. And if I subtract 56, I get 4. And I'm going to be right back to where I was before, with 40. So that, at this point, we're caught in a loop. And we would just keep going and going and going. So what that means is we're going to have a repeated decimal. So 6 divided by 0.7 is, in this case, 8.571428, like that. Okay, the reason I chose 7 is because it's the worst of the single digits for creating these ugly decimals. But yeah, there we go. And it would just be 8.571428, 57142, 57142 over and over and over and over again. All right, and that's how that works. Yeah, so sometimes we don't get perfect, things coming out perfectly and ending when we find out how to find out our decimals this way. Okay. Now, of course, in the field of medicine, right, you're never going to need to have, to the 10 millionth decimal place or anything like that, right? What you are going to need is, to 2 or 3 decimal places. So in that case, you would just round, which we covered just a few minutes ago. Okay? All right, so that is division with decimal numbers.